Hey everyone, welcome to AI Deep Hallucination. Today's question shows up in almost every AI interview. Interviewer, what is a transformer?
I've had this one twice. First time I said an attention-based neural network architecture. The interviewer's face didn't move, just said and. I totally blanked.
Yeah, that's the trap. Any candidate can say attention architecture, but the interviewer wants 5 layers of progression: definition, formula, traps, 2026 evolution, 3 deep follow-ups. Layer 3 gets you through, Layer 5 gets you the offer. Today we'll unpack it layer by layer. Layer 1, the one-sentence definition. A transformer is an encoder-decoder sequence modeling architecture that completely abandons recurrence and convolutions, using only attention.
Wait, completely abandons recurrence and convolutions is actually a big deal. Before 2017, almost all NLP was LSTM and GRU.
Exactly. The paper title Attention is All You Need pays tribute to the Beatles' All You Need Is Love, and it hit 28.4 BLEU on WMT English to German on its first try, beating every model at the time, trained on just 8 P100s in 3.5 days. Layer 2, you have to explain the core mechanism clearly. Start with what self-attention does. Picture the sentence, the cat chases its tail. When you read it, you need to scan the whole sentence to find what it refers to. That's what transformer does. Every word computes relevance with every other word, then mixes them weighted by that relevance.
It sounds a lot like a database select. Every word sends out a query and matches against all keys. No wonder Q stands for query and K stands for key.
Exactly, the formula is softmax of Q times K transpose divided by root dk times VQ is what I'm looking for, K is what I represent, V is what I carry. Q, K, V aren't the raw input, they come from multiplying the raw input by 3 different learned matrices. In multi-head, what we described is single-head. Multi-head means doing 8 independent attention ops in parallel, letting the model watch 8 different relation patterns at once. Some heads catch syntax, some catch semantics, some catch position. Concatenate, then multiply by 1 more matrix to integrate.
So, are more heads always better? Modern LLMs have dozens of heads.
The original paper did ablations, single head drops by 0.9 BLEU, too many also hurts. But the key insight is, each head's dimension d, k equals d model divided by h, so total compute for 8 heads is almost the same as 1 head at full dimension. It's a free expressiveness boost. One more, positional encoding. Attention has a natural bug, it's insensitive to word order. Dog bites man and man bites dog compute identically, so you have to inject position information explicitly. The original paper used sin and cos formulas added to the word embeddings.
Why pick sin and cos specifically? It feels mystical.
Here's the punchline: the original authors did ablations themselves and found, quote, the 2 versions produced nearly identical results. They chose sin cos only because, quote, it may allow the model to extrapolate to sequence lengths longer than the ones encountered during training. Even more humiliating, by 2026, industry has long abandoned sin cos. Post-Llama frontier models are basically all on row P. Last piece, the encoder-decoder split. Encoder looks at the whole input bidirectionally. Each word can attend to all words. Decoder only sees history and has an extra cross-attention sublayer with Q from decoder, K and V from encoder output. Today GPT, Claude, LLMA are all decoder only, but we'll come back to this. The encoder-only BERT family isn't dead. Layer 3 is the divider, 3 trap questions, and if the interviewer asks them, they're filtering candidates. Trap 1, why divide by root dk? Standard answer: if Q and K have independent components with mean 0 and variance 1, then their dot product variance equals dk when dk is large, dot product magnitude is large, pushing softmax into saturation, gradients vanish, training stalls. Dividing by root dk brings variance back from dk to 1.
I hear many people answer for normalization. That's not quite right, is it?
Right, normalization is vague. The precise answer is restoring variance to 1, and if the interviewer follows up why root not dk itself, dividing by dk compresses variance to 1 over dk less than 1, softmax output becomes too uniform, model loses discrimination. Missing this follow-up drops you a grade. Trap 2, why 3 different matrices for Q, K, V? What if they shared? Sharing makes the attention matrix symmetric and the diagonal is always the maximum. Every word always attends most to itself, model degenerates toward identity. Worse, you can't express asymmetric dependencies like it refers to animal. Trap 3, why LayerNorm not BatchNorm? 3 reasons: NLP sequence lengths vary, padding distorts batch statistics, long sequences force small batches, noisy stats, at inference batch equals 1, BatchNorm loses precision. LayerNorm normalizes along the feature dimension independent of batch. Okay, passing these 3 layers only means you understand the original paper. Layer 4 is where you start pulling ahead. The transformer in 2026 is not the transformer of 2017.
But if the skeleton has held for 9 years, doesn't that prove attention as the core was the right choice? Swapping parts is just turning the efficiency dial up.
Half-right, attention as an abstraction was the right choice, which is why it lasted 9 years. But what was chosen right was the abstraction, not every concrete part from the original paper. An independent survey of 53 modern open-source models, row P positional encoding at 70%, SWI glue activation also at 70%, GQA at 40%. MOE is more interesting, overall only 20%, but if you only look at models released in 2025, it jumps to 60%. None of these are in the 2017 paper. Most aggressive change is KV cache optimization. DeepSeek V2 introduced MLA multi-head latent attention. The official paper number is 93.3% KV cache reduction. Counted by per token element count, the community estimates that's roughly 57 times compression. We covered why KV cache is the inference bottleneck in our episode TurboQuant, Truth and Controversy. Check it out if you want. Flash attention, I/O or algorithmic optimization doesn't change the math, just memory access. The latest is Flash Attention 4, released March this year by TriDAO's team. On B200 with BF16, it hit 1605 TFLOPs per second, 71% hardware utilization. Third-party How AI Lab used mixed precision NVFP4 for QK, BF16 for PV, and on their own benchmark pushed it to 1801. And just today, April 16, 2026, Anthropic dropped Claude Opus 4.7, 1 million context plus 3.75 megapixel vision. Still a decoder-only transformer. 9 years from 2017 to today, the skeleton hasn't moved. Layer 5 is the offer level. You need to answer 3 deep follow-ups. Follow-up 1. Why did transformer beat RNN? 2 levels, math and engineering. Math. Bengio in 1994 used the spectral radius theorem to prove RNNs can't learn long-range dependencies. Gradients must decay exponentially. Engineering. RNN must unroll serially along the time axis. GPU utilization is terrible. Transformer parallelizes the whole sequence at once. The harder evidence is Kaplan 2020's Figure 7, same conditions, LSTM versus transformer. The conclusion, quote, the LSTMs perform as well as transformers for tokens appearing early in the context, but cannot match the transformer performance for later tokens. This is a ceiling problem, not effort. Follow-up 2. Will transformer be replaced? The most promising challenger is Mamba, selective SSM from December 2023, linear complexity 5 times inference throughput. But it has a weakness. At the same training budget, it clearly lags on copy, retrieval, MMLU tasks that need precise recall. In NVIDIA's empirical study at 8B scale, trained on 1.1 trillion tokens, Mamba 2's MMLU 5-shot was only 29%. Same-scale transformer was 46%, a 17-point gap. At 3.5 trillion tokens, the gap narrows to 1.4 points, catches up, but doesn't overtake.
So, did Mamba win or lose?
Neither. Mamba didn't lose. On March 17, 2026, Mamba 3 was open-sourced, to 7 times faster than Transformer at 16K length. Mamba didn't win either per public analysis. Frontier models GPT 5.4, Claude Opus 4.7, Gemini 3.1 Pro are still mostly Transformer. OpenAI and Anthropic haven't disclosed architecture details. The real ending is absorbed. Jamba, NVIDIA Nematron use hybrid architecture with Mamba as the cheap long-context layer, Attention as the precise retrieval layer. Notice a detail, frontier general-purpose LLMs are basically all decoder-only, but that doesn't mean the architecture itself is superior. Google DeepMind's own October 2025 Red LLM paper says literally, quote, such a shift mostly results from the success of GPT models, rather than the incapability of the encoder-decoder architecture. They also found zero-shot decoder-only is indeed stronger, but after instruction tuning, encoder-decoder catches up or even overtakes. That's a god-tier quote for interviews. Encoder-only isn't just alive, it's resurging. Hugging Face's October 2025 official download stats show encoder models account for 45% of all downloads. Decoder-only LLMs only 9.5%, nearly 5 times gap. Sentence Transformers is the #1 account on all of Hugging Face, and 64% of downloads from the Google org come from old BERT. Modern BERT hit 4.3 million monthly downloads within half a year and got accepted at ACL 2025. Descendants like BERT now cover 1,833 languages. As for cost, that famous late 2024 FineWeb case, filtering 15 trillion tokens cost $60,000 with BERT versus $1 million with the cheapest LLM, 16 times gap. BERT is doing just fine in production. Follow-up 3. Why can Transformer also do images, audio, video? Because attention isn't picky. It learns the relations between tokens. It doesn't care what the tokens themselves are, text, images, or audio. Images. ViT chops an image into 16 by 16 patches. Each patch is a token. A 224 by 224 image becomes 196 tokens. Audio, Whisper converts audio to MEL spectrogram. Original paper used 80 channels. Large V3 upgraded to 128, then convolutional downsampling. Video, Sora slices video into 3D spacetime patches, and there's a classic line from the Sora Tech Report. The Sora Tech Report has two lines that, stitched together, form the spiritual footnote for Transformers universality. First, whereas LLMs have text tokens, Sora has visual patches. Second, about the spacetime patches scheme, this scheme works for images too, since images are just videos with a single frame.
So essentially, Transformer is a universal tokenized interface plus attention mixer.
Karpathy has a classic line: Transformer is, quote, a magnificent and resilient general-purpose differentiable computer. It's simultaneously expressive, optimizable by gradient descent, and hardware-friendly. That three-way balance is what RNN and LSTM couldn't pull off. One last Easter egg. Last October, one of the 8 original authors, Leon Jones, now co-founder and CTO of Sakana AI, spoke at the TED AI San Francisco conference. VentureBeat reported his literal words, "I'm absolutely sick of them. The inventor himself has had enough." Just today, Anthropic dropped Opus 4.7 architecture unchanged, still Transformer. 9th year in, answering this question across all 5 layers, from 1-sentence definition to attention formula to 3 traps to 2026 with parts all swapped to 3 deep follow-ups, basically gets you an offer-level answer. What other interview question do you want us to unpack? Drop it in the comments. If this was helpful, hit subscribe and we'll see you next time.